If you think back, like, just a few years to the early 2020s, I mean, the headlines were completely dominated by this very specific kind of hype.
Oh, yeah. We were talking about, digital real estate in the metaverse
Right.
and those highly speculative JPEGs of apes. Companies promising to completely revolutionize the world, but with absolutely no coherent business plan.
Yeah, it was just an era of incredibly cheap capital and wild speculation. But as we welcome you to today's deep dive into the source material, I actually want you to picture something entirely different.
Something very physical.
Exactly.
Yeah.
Picture millions of tons of steel, concrete, and just endless fiber optic cables being laid across the globe.
It really is a profound pivot
Wow.
because this speculative fog is kind of cleared out. And according to the 2026 Global Strategic Intelligence Report that we are analyzing today, we've officially entered what they call the era of institutional realism.
Which sounds intense.
It is. I mean, capital isn't just chasing disruption for the sake of disruption anymore. We're watching the permanent physical infrastructure for the next century being built in real time. And it is backed by staggering amounts of institutional money.
Okay, let's unpack this because we're going to look at four massive pillars from our sources today that prove this shift is happening right now. And more importantly, how they are all deeply connected.
Right, because they definitely are.
Yeah. So we're looking at them. They really are.
Global health, finance, and computational power are being fundamentally re-architected to feed into one another.
Let's start with the computational power because the numbers in this Futurum research report are, honestly, they're almost hard to comprehend.
They're astronomical.
Yeah. The big five U.S. hyperscalers, so that's Amazon, Alphabet, Meta, Microsoft, and Oracle, they're committing between $660 and $690 billion to capital expenditure in 2026 alone.
Just in 1 year.
Just 1 year. To put that in perspective for you, that is nearly double what they spent just a year ago in 2025.
They're essentially rebuilding the global compute grid from the ground up. I mean, Amazon is leading the pack with a $200 billion deployment plan all by itself.
Wow.
And then you look at the Stargate project. That is a $500 billion infrastructure ambition involving OpenAI, SoftBank, Oracle, and the current administration.
Right, aiming to build massive data centers across Texas, New Mexico, and Ohio. But see, here's where I have to push back on the logic of these numbers. Because I'm looking at the revenue gap, and the math just feels incredibly wobbly to me.
How so?
Well, you look at the pure play AI vendors, right?
Mhm.
The companies this infrastructure is supposedly being built to support, OpenAI is doing incredible numbers. They hit $20 billion in annual recurring revenue.
Which is a massive milestone, yeah.
And Anthropic surpassed a $9 billion run rate. But if you combine all of them, like OpenAI, Anthropic, Cohere, Mistral, Perplexity, their total projected 2026 revenue is, what, less than $35 billion?
Yeah, that's accurate. You are seeing a $35 billion demand signal against a nearly $700 billion supply cost.
Yes. It feels like we are building the entire interstate highway system, paving millions of miles of concrete across the country before the Model T has even been mass-produced.
I think why it looks that way.
I mean, is this just the biggest financial bubble in history? If the revenues of the AI companies don't match the spend, who's actually buying all this compute?
If we connect this to the bigger picture, the hyperscalers are not just building this infrastructure for third-party AI vendors.
They aren't.
No. And that assumption is the single most common misconception in the market right now. They are building it for massive enterprise adoption across every non-tech sector of the economy, and frankly, for their own internal services.
Okay, but still, $700 billion.
Well, every single one of these hyperscalers is reporting that they are supply constrained, not demand constrained.
Wait, how can they be supply constrained when they're spending $700 billion? That doesn't make sense.
Because physical reality is getting in the way. Look at Microsoft's latest filings. They disclosed an $80 billion backlog of unfulfilled Azure orders.
$80 billion just sitting there.
Yes. That is $80 billion sitting on the table from everyday businesses trying to run enterprise AI workloads, and Microsoft literally cannot process the orders.
Oh, wow.
They cannot build the physical data centers fast enough. Or, more importantly, they can't find enough electricity and cooling systems to meet the demand.
So, to borrow my own metaphor, they aren't waiting for the cars to be built. The cars are already built, and they're stuck in a massive traffic jam waiting for the highway to open.
Exactly.
Think of it like trying to run your air conditioner, your microwave, and your hairdryer all on the exact same electrical circuit. The demand is there, but the grid just trips.
That is a perfect way to visualize it. And what's crucial for you to understand as a listener is that this massive compute power isn't just sitting idle, waiting to generate text for a chatbot.
Right, it's doing real work.
Exactly. It is actively commoditizing the research phases of other industries. This heavy computational lifting is fundamentally changing how we approach biology, for example.
Yeah, the Global Strategic Intelligence Report calls this the biocompute arbitrage loop, which is a mouthful.
It is, but it's brilliant.
Historically, if you were a biotech startup, you were what they call wet lab first. You had to raise tens of millions of dollars to buy physical pipettes, petri dishes, mass spectrometers.
Highly specialized supercomputers.
Right. All that stuff just to begin your research. Now, because there is so much AI compute available to rent from these hyperscalers, that physical hurdle is just, it's gone.
You can launch a compute-first biology company now. You run the simulations in silico, which basically means entirely on rented computer servers before you ever touch a physical test tube.
The report highlights Diogen's biotechnology as the prime example of this.
Oh, yeah. What they're doing is wild.
They are using AI models to reduce the time it takes to perform complex chromosome analysis from 30 days down to less than 1 week.
Which is incredible for the science. But, discovering a drug or an analysis method on a server doesn't magically put it in a pharmacy.
Right. You still have to prove it works in human beings.
Exactly. And that is where the speed of AI crashes headfirst into the friction of medical regulation.
Because if you invent a drug in 6 months using AI, but it still takes 10 years to get it approved for human trials, the computational speed is completely useless. You're just sitting at a different red light.
Fast-tracked computational science requires a fast-tracked regulatory system to actually yield results. The software has completely outpaced the bureaucracy.
Here's where it gets really interesting, because a regulatory fast track actually now exists, and it is reshaping the global pharmaceutical map.
Yes.
Enter the Greater Bay Area, or GBA, in China. They have rolled out a policy called the Medicine and Equipment Connect.
It's a game changer.
Under these updated regulations, drugs and medical devices that are urgently needed and already registered in Hong Kong or Macau can be used directly in mainland GBA hospitals, like the HKU Shenzhen Hospital.
And they could do this without having to go through the prior registration with China's National Medical Products Administration, the NMPA.
Which normally takes forever.
Exactly. And you have to understand the scale here. The GBA isn't just a handful of clinics. It is a massive megalopolis with a population of 86 million people.
And the timeline is what truly makes this a highway. I mean, the review periods under this new policy are 10 working days for items already on their listed import catalog.
10 days?
10 days.
Yeah.
And just 20 days for non-listed items. They've even eliminated port inspections to speed up customs. So you go from literally years of bureaucratic red tape to a 20-day turnaround.
This GBA-first strategy is the ultimate testing ground for institutional realism. Regulators are actively removing the bottlenecks so that the accelerated AI drug discovery can reach patients.
It's a physical infrastructure catching up to the digital.
Exactly. But the most valuable export from this process isn't just the health outcome, it's the data. By deploying these therapies in the GBA, companies are generating massive amounts of real-world evidence, or RWE.
Which is the clinical data gathered from actual patients in real hospitals, rather than just controlled, isolated clinical trials.
Right, and the NMPA explicitly recognizes this real-world evidence to support future nationwide rollouts across the rest of China.
So you can see the pipeline forming here. You use rented AI compute to discover a drug in a fraction of the time. You use the GBA regulatory highway to get it into clinics in weeks. And you use the real-world data from those clinics to conquer one of the largest healthcare markets on the planet.
But, and there's always a, but that leaves a massive operational gap.
Yeah, I was going to say, a compute-first biotech startup with, 20 engineers and biologists? They don't have the global supply chain to manufacture millions of doses.
Or the sales teams to distribute them.
Right. So what happens to these hyper-efficient startups when they actually hold a proven de-risked drug in their hands?
They become prime acquisition targets.
Of course.
The legacy pharmaceutical giants, the massive companies with the global supply chains, they're currently staring down the barrel of massive patent cliffs.
Meaning their blockbuster drugs are losing exclusivity.
Exactly. They are desperate to replenish their pipelines, and they have billions in cash ready to deploy.
Which perfectly explains the third pillar in our source stack today, Gilead Sciences. We're looking at a major move detailed in an Xtox analysis. Gilead has entered a definitive agreement to acquire Arrow Medicines for up to $2.2 billion.
That's a massive deal.
It is. It's structured as $1.7 billion upfront, with another $500 million in milestone payments.
And it's incredibly front-loaded, especially considering Arrow only emerged with its first-round funding a year ago.
A year ago, that speed is insane.
But to understand the price tag, you really have to look at the specific asset they're acquiring.
Well, Gilead is historically famous for its dominance in HIV and oncology treatments, but Arrow is completely focused on autoimmune diseases.
Right.
The crown jewel of this $2.2 billion deal is a clinical stage drug called OM336, or gamgertamig, if you want the generic name.
Gamgertamig.
The technical term is that it's a BCMX CD3 bispecific T-cell engager, or TCE.
That's a lot of acronyms.
It is. The goal of the drug is rapid, deep B-cell depletion to treat severe autoimmune conditions like systemic lupus and rheumatoid arthritis.
Let's break down the biological mechanism there because it's brilliant.
Please do.
So in an autoimmune disease like lupus, certain immune cells, specifically B cells, they kind of go rogue. Instead of producing antibodies to fight off infections, these B cells act like corrupted factories,
Making bad stuff.
producing autoantibodies that actually attack the patient's own healthy tissues.
So you need to shut down the corrupted factories.
Precisely. Now, your body has a built-in assassin to handle problematic cells, which is the T cell.
Okay.
A bispecific T cell engager is essentially a molecular handcuff. One end of the drug grabs onto the T cell assassin. The other end grabs onto the rogue B cell. It physically drags them together, forcing the T cell to recognize and destroy the B cell.
Wow, so it's literally weaponizing the patient's own immune system to clear out the corrupted cells.
Exactly.
And because rogue B cells are the root cause of multiple autoimmune diseases, so not just lupus, but rheumatoid arthritis and others, Arrow designed this drug as what they call a pipeline and a product.
Which is a huge selling point.
Yeah. If you prove the mechanism works, you can potentially treat a whole umbrella of conditions with this single asset.
What's fascinating here is how this reflects modern biotech M&A mechanics.
Mergers and acquisitions, yeah.
The X-Talks report highlights a major industry shift toward asset-centric venture funding. Big pharma companies like Gilead are effectively outsourcing their early-stage research and development.
Because instead of pouring billions into their own massive, speculative internal research labs that might yield absolutely nothing, they just wait for a nimble startup to take the initial risk.
Exactly. I mean, Arrow actually licensed OM336 from Gilead Biosciences in China, ran the early trials, and proved the concept.
So Gilead doesn't want to build the underlying tech from scratch. They just want to buy the highly de-risked, proven asset and plug it into their massive global commercialization engine.
Right. And there is even a unique operational detail here. Gilead's Belgian partner, Galapagos, is in advanced discussions to take on the remaining clinical R&D and actually absorb Arrow's workforce.
Wow, so everybody wins. Gilead gets the drug, Galapagos gets the specialized talent, and the original investors get a $2.2 billion exit.
It is an incredibly efficient reallocation of capital. But historically, getting bought out by big pharma or begging traditional venture capital firms for money were the only ways a small biotech could survive the astronomical costs of clinical trials.
Which brings us to our final source, and probably the most surprising connection in this entire dope dive.
Oh, definitely.
A landmark shift in financial regulation might completely change how the next generation of life-saving research is funded.
We are looking at the SEC's recent comprehensive clarification regarding crypto assets.
From March 17th, 2026.
Yes. For over a decade, the digital asset industry operated under a total cloud of ambiguity.
Yeah, the industry always called it regulation by enforcement. It was like sitting down to play a complicated board game, but the referee flat out refuses to give you the rule book. Instead, every time you make a move, they might randomly flip the board over and penalize you. You just can't build a sustainable business in that environment.
But that environment has fundamentally changed. The SEC issued a landmark interpretation establishing a coherent taxonomy. They drew clear lines distinguishing between digital commodities, collectibles, network tools, stablecoins, and actual securities.
Led by SEC Chairman Paul S. Atkins, right?
Yes, and CFTC Chairman Michael S. Selig joined the interpretation to harmonize the rules. They even provided frameworks for how an investment contract can successfully come to an end and address things like airdrops and staking.
And at the same time, we saw the Genius Act formalize payment stablecoins. The Wild West days of unbacked digital money are just over.
Oh, completely over.
If you issue a payment stablecoin today, you are required by law to hold one-to-one reserves in high-quality liquid assets, like U.S. Treasury bills or cash.
And rehypothecation, the practice of lending out those reserves to generate risky yield, is strictly prohibited now.
It is a profound integration. Digital assets are no longer existing in a shadow economy. They're being integrated into the core prudential frameworks of the global banking system.
We are seeing identical shifts internationally, too.
Yeah.
Like in Hong Kong, where the Securities and Futures Commission is now allowing licensed intermediaries to provide margin financing for crypto, accepting digital assets as collateral for professional investors.
So what does this all mean? If you're listening to this and you have zero interest in trading digital assets and you don't care about margin financing in Hong Kong, why does an SEC taxonomy matter to the broader picture of institutional realism and global health?
Because of the hidden synergy. The Strategic Intelligence Report refers to this as the true alpha insight of the decade.
Alpha insight, I like that.
With legal clarity finally established, the most disruptive application of blockchain technology isn't buying a cup of coffee with a stablecoin.
Right.
It is a movement called decentralized science, or DeSci.
Decentralized science. Okay, let's map out exactly how that connects back to the biotech startups and the drug discovery we were just analyzing.
Think about the massive hurdle we discussed. A small group of brilliant scientists uses AI to discover a promising treatment for a rare orphan disease.
Okay.
But they don't have the $50 million required to run global clinical trials. In the past, they had to surrender their intellectual property to a massive venture capital firm, or sell out entirely to a legacy pharma company.
But with the SEC's new regulatory clarity, specifically the Project Crypto exemptions detailed in the intelligence report, a third option opens up.
Right.
These scientists can use tokenized intellectual property to fund their research directly.
Let's look at the mechanics of how that actually works. Instead of seeking one massive check from Wall Street, the startup can encode the intellectual property of their drug patent into a smart contract on a blockchain.
Which is legally compliant now.
Yes. They can then issue digital tokens that represent fractional ownership of that specific drug's future revenue.
It is essentially highly regulated, globally accessible crowdfunding. But instead of getting a t-shirt for your donation, you own equity in the actual scientific breakthrough.
And because it leverages stablecoins and borderless liquidity pools, a retail investor in Tokyo, an institution in London, and a patient advocacy group in New York can all seamlessly fund the development of this orphan drug in real time.
That's incredible.
The SEC framework makes this legally compliant, bypassing the traditional Wall Street gatekeepers entirely.
It is an astonishingly cohesive picture. When you pull back and look at the entire landscape we have traversed today, the era of institutional realism is a completely new end-to-end architecture of value.
The tools that were considered fringe or speculative just 5 years ago are now the highly regulated bedrock of human progress.
Let's recap the journey. We started with the hyperscalers pouring $690 billion into AI compute infrastructure, transforming biological research from a slow, physical wet lab process into a high-speed computational simulation.
Right.
We saw how the Greater Bay Area's massive regulatory highway allows those simulated discoveries to reach patients and generate clinical data in a matter of weeks, not years.
Which leads to the buyouts.
Exactly. We watched legacy pharma companies like Gilead deploy billions of dollars to acquire these de-risked autoimmune therapies to survive their patent cliffs. And finally, we saw how the SEC's new regulatory clarity empowers the next generation of scientists to fund their research directly from the public via tokenized IP.
It is a perfectly optimized global pipeline. However, this raises an important question, and it is a systemic risk the intelligence report warns about, calling it the power wall.
The power wall. This goes back to the $80 billion Microsoft backlog, the physical constraints of the grid.
Precisely. All of this innovation, every AI simulation, every blockchain transaction, every piece of real-world data relies on physical energy.
It all plugs into the wall.
And global data center electricity consumption is currently doubling. As these massive 5-gigawatt data centers come online over the next few years, AI compute is going to transition from a corporate service into a critical sovereign resource.
Which means we are approaching a horizon of zero-sum physical choices.
Yes, In the very near future, local governments and nations are going to have to make incredibly difficult decisions regarding their power grids.
Like what?
When the grid is stressed, do you route the available electricity to keep the lights and heating on in a residential city? Or do you route it to the data center that is currently crunching the AI simulation required to cure the next pandemic?
Wow. The digital infrastructure of the future is fully mapped out, but the physical resources of the present might not actually be able to sustain it. It leaves us with a profound realization about the era we are entering. We are no longer waiting for the technology to arrive. We are desperately trying to build a physical world capable of holding it. Thank you for joining us on this deep dive into the source material. We hope this leaves you with plenty to think about. Keep questioning the connections between the technology in your pocket, the medicine in your cabinet, and the massive infrastructure being built all around you. See you next time.